Hello everyone. This question has been taken from Irodov, Fundamental Equation of Dynamics, question number 60. The question is in the arrangement of figure 5 1.9. So this is the figure. The masses m0, m1 and m2 of bodies are equal. So these three masses are equal. The masses of the pulley and the threads are negligible, means we can consider them at 0. And there is no friction in the pulley. Okay. Find the acceleration w with which the body m0 comes down and the tension of the thread binding together the bodies m1 and m2. If the coefficient of friction between these bodies and the horizontal surface is equal to k, consider possible cases. They're saying that friction is available here between the bodies and the surface. This one is free and not touching the any surface and no friction force on this. Okay. And the whole system is connected with the thread, which is inextensible and massless. So means when m0 will come down with w, m1 will also move with w and m2 will also move with w acceleration. So let us solve this question. First we should collect all the data like what is given. So we are writing for our convenience m0 is equal to m1 is equal to m2 as per question. That is why it is said given. Mass of the pulley is negligible, so 0. Mass of the thread is negligible, so 0. Coefficient of friction between bodies and surface is k. Okay. And what to find out? To find out acceleration w of block m0 with which it will come down, and tension in the thread binding block 1 and 2. That is T1, 2. So what is the shortest way of solving it? We will take this complete as a system. Pulley and mass system. Okay. The whole thing is means each and every part of this system is moving with acceleration w. Okay, so we should basically, when we are taking this as a system, so we can calculate what is the unbalanced force acting on the system. This unbalanced force is nothing but the external forces acting on this system. So what is the external forces acting on it? One is the m0 g, the pull of the gravitation. Here, since this is coming down with w, so this is also coming, so this is also moving with w in this direction, this one also. So there will be friction between the bodies m1 and the surface and m2 and the surface. So we should say it as f1 and f2. So these two are the external forces. The other external forces that will be acting on it is m1g and the normal reaction force with which the surface is pushing it up. So it is basically counterbalancing the weight. So there is no net force acting in the vertical direction. Same is the case with m2. So we will make the free body diagram of m0 first. Okay. We assume that in this thread the tension is T. This is T. This one is your m0 block. Okay. It is coming down with W. External. This is the force m0 G which is acting on it. Same way for FBD of m1. This side the tension force, so tension force is acting here. m1g is acting downward, but normal reaction which the surface is providing is n1, which is here. Okay, in the upward direction. This block is moving with W in this direction because m0 is coming with W. This one will also go with W in this direction. This tension in this thread we have taken it as T12, means tension in the thread connecting 1 and 2, M1 and M2 mass together. So T12, this is the force F1. So how will you calculate F1? F1 you know that K into N1, and N1 you are knowing that N1 is nothing but it is equal to M1G because there is no acceleration in the vertical direction, so no unbalanced force acting in the vertical direction. So therefore your F1 will become K is equal to M1G. Similarly, we will write equation for M2. M2, this thread tension T12 will be acting on it, moving with acceleration W. This is the non-ball reaction provided by the surface on M2. M2G is the gravitational pull on it, and F2 is the friction force. So again, the friction force will be K into N2, and N2 is nothing but K M2G. Okay, so M2G, so F2 will be K into M2G. So here we have reached all the things you can go through. So what I've written here for your understanding. Since the whole system is moving with acceleration W, so the unbalanced external force responsible for the motion is the gravitational pull on M0, that is M0G. The external other force is F1, which is resisting the motion. So F1 is the external force minus F2. So this is the unbalanced force which is working in the motion of the block and thread assembly. And now each system is moving with W, so we can calculate unbalanced force divided by total mass of the system as the W. So we will put the value, and we are getting this W is equal to M0 minus K into M1 minus K into M2, the whole thing in bracket, into G divided by M0 plus M1 plus M2. So this is the acceleration which the system will move. The other thing which we have to find out is T12. So we will refer the FPD of block 2. T12 will be, T12 is in the horizontal direction, and horizontal direction acceleration is W of M2. So we can write M2 into W. So M2 into W we can put from equation 7. So this is for T12 we have got. Okay, this we should say as equation 8. Okay, so W you got. Now the second part, it is asking that possible cases. So what is the possible cases? So we can go on in equation 7 and start looking into it. So we should consider case 1. If the value of K is equal to 0.5, so what will happen? 0.5 into M1 minus 0.5 into M2. M1, M2 and M0 is same as given in the questions. So this numerator will become 0. So there will be no motion. So in case when the value of K is equal to 0.5, the system will remain stationary. Second case, if the value of K is greater than 0.5, so what is happening? Sum of these two will be greater than this M0. So numerator will become negative. So what does this mean? The system will move in the opposite direction, but it is not possible because M0 G is the force which is setting up the motion in the system. Okay. So when K is greater than 0.5, so it is not possible. Okay. So this case 2 is not possible. Third one is for the motion to occur, the value of K must be lesser than 0.5. So when it is 0.5, so this numerator will become positive and the system will move with a certain acceleration w depending on the value of k, because m0, m1 and m2 are the same. So hopefully you understood the solution. You can go through the points which I have written up in this solution. And in case any doubt, please do let me know through your comment. I will explain it. Thank you.